பேப்பர் இருக்கா சார்? அட்டெண்டன்ஸ் இருக்கு. பரவாயில்ல, ஒரு பேஜ் இருக்கு. ஓ, இவன் நோட்டு இங்கே தான் இருக்கா? இவன் போன வாட்டி நோட் எடுத்துட்டு வரலன்னு சொன்னான். சீக்கிரம் போங்க. Write your names, all of you. Huh? என்ன அது எழுத முடியலையா உன்னால? எழுத முடியலையா? ஃபோட்டோ எடுக்கிறியா?
இல்ல இல்லங்க அம்மா, நான் ஸ்டூடியோ நல்லா இருக்கும் எப்படி இருக்கும் ஃபோட்டோ அனுப்புங்க.
மைக் ஆனா? எத்தனை நேரம் ஒன்றில் தான் இருந்தது? Started. See, if you don't write your names, you will not get attendance. இருக்கிறது மட்டும் நம்ம நோட் பண்ணிக்கலாம். அந்த பேப்பரை தரேன், ஆன்லைனில் இருக்கிறவங்க பேர் மட்டும் நோட் பண்ணிக்கோங்க அட்டெண்டன்ஸ்க்கு. ஸ்க்ரீன்ஷாட். Yeah, good evening all of you. So today we will have current electricity MCQs. So before we start, these are the important formula that you will require to work out all the numericals. See, what is this lesson all about? Current electricity, flow of charges through a conductor. What are the factors affecting it? Okay, resistance affect pandra factors, all that. So most of the formula I have written. One is the current through a conductor. இது எப்படி derive பண்றோம்? Suppose you have a conductor, you apply a potential difference to it. You will create an electric field. Electric field create பண்ணும்போது ஒரு potential difference இருக்கும். As a result, electrons will start flowing from one end to the other. அப்படி flow ஆகும்போது it will collide with the other electrons and other atoms on the way. Finally, ஒரு average velocity ல, it's not uniform. Sometimes it will collide, it will come to rest. Again, it will be accelerated due to the electric field. Finally, அது என்ன ஆகும்? ஒரு எண்ட்ல இருந்து இன்னொரு எண்டுக்கு it will reach with an average velocity. That average velocity is called as drift velocity of the electron. And the equation relating the current and drift velocity is given as I is equal to NAEVD. Now here N is very specific. It is number density of electrons in the conductor. Number density na number of electrons per unit volume. Don't take it as capital N. Okay, small n is number density of electron, number of electrons per unit volume. A is area of cross section of the conductor that you have taken. Small e is the charge on an electron and Vd is your drift velocity. Now, the drift velocity is directly proportional to the electric field that you have applied. ஒரு conductor எடுத்து அதுல electric field you are applying, a positive and negative potential you're giving. Adukku directly proportional ah irukum drift velocity. BD is equal to small e capital E tau by m. How do we derive this? You know that acceleration is equal to force by mass. F is equal to ma. F is equal to ma. Suppose you have an electron E placed in an electric field. What will be the force on the electron placed in an electric field? Q into E. So you can also write it as small e into E, where Q is the charge on the electron, is equal to m into A. Now acceleration A is equal to small e capital E divided by m, where m is the mass of the electron. Now velocity is equal, acceleration is equal to change in velocity, drift velocity by time taken. Now this tau is the mean free time. ரெண்டு successive collisionக்கு நடுவுல கிடைக்கிற அந்த time gap தான் tau. So acceleration is equal to Vd by tau. So Vd is equal to A into tau, acceleration into time. So acceleration E by m, that is how you get Vd is equal to E capital E tau by m. Okay. For the second batch, if he has not taken current electricity, you will learn these are the formula that you require to work out the numericals today. So shall we move on to the first question? Here. And where in a basic knowledge theva series arunda edhu constant ah irukum? If there is only one way for the current to flow, the current in the circuit will be constant. And if it is parallel circuit la potential difference, voltage will be constant. Now here, power dissipated across 8 ohm resistor in the circuit shown here is 2 watts. Power ku enna formula irukku? Power ku enna formula? No, not that, and not in mechanics. In electricity, V into I, potential difference into the current. P is equal to V into I square R or V square by R. Please note. Power P is equal to potential difference into current. In the product தான் power னு சொல்றோம். Or it is also written as I square R. It can also be written as V square by R, applying Ohm's law. These are three formula that you can apply for power. In the case la V square by R எடுப்பேன், in the case la I square R எடுப்பேன். Generally, V into I you can take in any case. It is always going to be a constant. If it is a series, then I will be constant. Power you, resistance you, relate பண்ற equation, you will take P is equal to I square R. And if it is a parallel connection, you will go for P is equal to V square by R. Now here, what connection do you have here? Is it a parallel connection or a series connection? 1 and 3 are in series. 1 and 3 are in series, and the combination is in parallel to 8 ohm. So what will be constant in both the cases parallel? The potential across 8 ohm, adhe dhaan potential across 1 and 3. Isn't it? Nah. So draw the diagram. All of you have written your names, attendance. Yes, ma. Sorry, I can't hear you. You were not present for the lesson, current electricity. You understood what I said. Can you please You can't hear? Can't you hear me? Okay. So here we have a series and parallel combination. இதுல வந்து current வந்து different இருக்கும் for both the branches. Let the current through the first branch be I1 and the current through the second branch be I2. So எது constant இருக்கும்? Potential. So I1 into the total resistance in one branch. What is the total resistance in the first branch? 4. That will be equal to I2, the second current through the second branch, into what is the resistance over there? 8. Now ரெண்டுலயுமே I1ங்கிற current தான் flow ஆகும். But they have not given any data about what is the current, எவ்வளோ split ஆகுது, என்ன ratioல, that they have not given. So let us take as I1 and I2 be the current flowing through the two branches. So you will only get the ratio between I1 and I2. So I1 will be equal to 2I2. Now you require the power across which resistance? 3. P is equal to I square R. So I1 square into the resistance whichever they have asked. What is the value of I1? I1 square into the resistance 3, but that is equal to 2 into I2 the whole square into 3. Now the power across 8 ohms they have given as 2 watts. So power I square into 8 is equal to 2. So what will be I2 square? 1 by 4. What is I2 square from this equation? See, I2 square into 8 is the power dissipated across the 8 ohm resistance. Adila they have given that it is 2 watts. So I2 square kandupidichidalam. I2 square is 2 by 8, 1 by 4. So this is 4 into I2 square into 3. Now I2 square is 1 by 4. So you will get answer as 3 watts. You're not given I1, I2 எதுமே தரல. ஒரே ஒரு விஷயம் நமக்கு என்ன தெரியும், parallel இருந்தா the potential drop across both the branches is going to be same. So first branchல இருக்கிற current let it be I1 which is passing through both 1 ohm resistance and 3 ohm resistance. The second current is I2 which is passing through 8 ohms. So power dissipated here they have given as I2 square R, that is I2 square 8 is equal to 2 watts. But you get the ratio between I1 and I2. Ratio தான் கிடைக்குது. அதுல இருந்து I2 square calculate பண்ணிட்டு. So the answer is 3 watts. So I1 into 4, and the 4 எப்படி வந்தது? 3 1 ஓட combination. 1 ohm and 3 ohm are in series. So the total resistance is 4. I1 into 4 is equal to I2 into 8. I1 is equal to I2 into 2. That ratio you get. So I2 square into 8 is equal to 2 watts they have given. So I2 square substitute panna you get 3 watts. The electrical resistance of a certain wire of iron is R. If its length and radius both are doubled, then the resistance will be doubled. The specific resistance will be half. What do you mean by specific resistance? Resistivity. அந்த என்ன மெட்டீரியல் எடுத்திருக்கோமோ அந்த மெட்டீரியலோட நேச்சர் as well as டெம்பரேச்சர்ல மட்டும் டிபெண்ட் பண்ணும். சப்போஸ் யூ ஆர் சேஞ்சிங் த மெட்டீரியல், the specific resistance will change. Otherwise என்ன லெங்த் என்ன டைமென்ஷன்ல எடுத்தாலும் காப்பரோட specific resistance is always same. Okay, அதே மாதிரி அலுமினியம், when you change the material the specific resistance changes, resistivity changes. Resistivity depends only on the nature, but என்ன length என்ன dimension எடுத்தாலும் specific resistance will never change. Resistivity will always be same as long as you don't change the material. இப்போ என்ன பண்ணிருக்கோம்? What is the equation relating? Yeah, resistivity R is equal to rho L by, yes, sixth one. R is equal to rho L by, rho they have not changed, specific resistance will not change. Then what have they done? They have doubled the length and doubled the radius also. Radius na cross section of a wire is always taken as a circle. Or wire or cross section, it is always a circle. So pi r square is the area. So if you double the radius, what will happen to the area? The area increases 4 times and length is increased 2 times in this case. So length double anadhukaga resistance double agum, but the radius has been doubled, so the area will increase 4 times. The ratio is 2 by 4. So what will be the final answer? Half of the initial resistance. So the resistance will be halved and the specific resistance will remain unchanged. Option 2. Remember one thing, resistance depends on dimension. Length, area of cross section la resistance depend pannum, but specific resistance or resistivity never changes unless and until you change the material. Next one, third question, amount of charge in coulomb required to deposit 1 gram equivalent of a substance by electrolysis. 1 gram equivalent of any substance to get, you should give up how many number of electrons? Avogadro number of electrons. What is the Avogadro number? 6.023 into 10 power 23. அத்தனை electrons கொடுக்கணும். ஒரு electron ஓட charge எவ்வளோ? 1.6 into. So multiply both and you will get the answer. You have to give out 1 mole of electrons, Avogadro number of electrons into the charge on a single electron. Calculate ma. So 96,500. 96,500 coulombs. You got the answer. Next, for a V-stone bridge, the arrangement of 4 resistors are P, Q, RS. P by Q is equal to R by S. Adhe order la kuduthirukanga. R1, R2, R3, R4. What is the order? What is the balancing condition? V-stone bridge la R1 by R2 by R1. R1 by R2 is equal to R3 by R4. Cross multiply panna R1 by R3 is equal to R2 by R4. I think potentiometer is a deleted portion for you. அது உங்க portionsல கிடையாது. Potentiometer is more accurate and versatile because அது galvanometer அளவுக்கு கூட current consume பண்ணாது, voltmeter அளவுக்கு. So a condition of no current flows through the galvanometer, so it is more accurate, but it is anyhow out of portion. Ohm's law is not obeyed by vacuum tubes, electrolytes, discharge tubes, all of these. All of these. எதை obey பண்ணும்? Which are ohmic devices? Wires generally. Then resistors and capacitors are ohmic devices. Resistors and capacitors are ohmic devices. Electronic devices like the transistors, diodes, vacuum tubes, இதெல்லாம் வந்து ohmic. What is the difference between ohmic devices and non-ohmic devices? Which follow, which obey Ohm's law are called as ohmic devices. அதனோட graphical representation எப்படி இருக்கும்? They will have a linear graph. Non-ohmic devices க்கு curve. Non-linear இருக்கும் graph. Two identical cells when connected in series or in parallel supply the same amount of current through an external resistance of 2 ohms. The internal resistance of each cell is ரெண்டு செல்லை சீரீஸ்ல போட்டோம்னா what will be the current? And அதே ரெண்டு செல்ல parallel போட்டோம்னா what will be the current? செல்லுக்கு internal resistance இருக்கு small r. So first caseல சீரிஸ்ல என்ன ஆகும்? The internal resistance will get added up. Second caseல it will get halved, r by 2. So first caseல cells is in series. So current I is equal to epsilon by r, the EMF supplied by the cell divided by the total resistance. Okay va? So I is equal to general equation epsilon divided by r. First case la you're connecting the two cells in series and they have the same EMF, same internal resistance. So total EMF will be 2 epsilon divided by that is series. And then parallel போட்டோம்னா when you connect two cells in parallel, what will be the total EMF supplied by the cell? parallel போட்டோம்னா எத்தனை செல் போட்டாலும் ஒரு செல்லோட EMF தான் தரும். Okay, if you connect in series, general equation epsilon in series will be equal to n times the EMF supplied by a single cell. Series case la parallel இருந்ததுனா it will always be epsilon only. ஒரு single cell கொடுக்கிற EMF தான் எத்தனை செல்ல parallel போட்டாலுமே தரும். So here it will be epsilon divided by but r by 2. And there is an external resistance also in this case. Or external resistance where irukku. That is in series, right, across. So plus 2 and then here these two are equal. Then calculate the internal resistance. Equation 1 and equation 2 are equal. They have said that the current through the series connection as well as the parallel connection is same. அப்படினா small r ஓட value என்ன? Calculate. These two are equal. Equate and then find out the value of small r. Anshul, Saravanan, Navina, Kirti, switch on your cameras. Mithun, Akshaya. Yes, 2 ohms. Two ohms. Next one. A battery consists of a variable number of identical cells, each having internal resistance R, which are connected in series. The terminals of the battery are short circuited and the current I is measured. Which of the graphs shows the correct relationship between I and N? A battery of variable number of identical cells. But you're shorting it in all the cases. First case la rendu cell illa moonu cell போட்டுட்டு என்ன பண்றோம் battery short பண்ணிடுறோம் positive and negative. Shorting means what? Positive and negative terminal la direct connect பண்ணி விடுறதுக்கு பேர் தான் shorting. Shortest you don't that is the shortest path that can be given. So current எப்போதுமே என்ன பண்ணும்னா தனக்கு இருக்கிற shortest path தான் அது follow பண்ணும். ஒரு pathல 8 ohms resistance இருக்கு இன்னொன்னுல 2 ohms தான் இருக்குன்னா current will naturally flow through the 2 ohm resistance, higher amount of current. Short circuit பண்ணா that is the shortest path that can pass through it. அப்ப எத்தனை செல் போட்டாலுமே the current will be same தான் இருக்கும். எத்தனை செல்ல கனெக்ட் பண்ணாலும் because you have shorted the two terminals, so the answer will be B. it will be whatever be the number of cells, எத்தனை resistance அதை affect பண்ணாது. The current will be same. The internal resistance of a cell of EMF 2 volt is 0.1 volt, 1 ohms. It is connected to a resistance, external resistance, capital R, 3.9 ohms. The voltage across the cell will be, they have asked V. Internal resistance or the formula? C. How did you get? What formula did you apply? Huh. Internal resistance R is equal to epsilon minus V by I, where I is the current through the circuit. V is equal to I into capital R. I எப்படி கிடைக்கும்? V is equal to I into the external resistance. Now what will be the current flowing through the circuit? When you have the resistance, external resistance or internal resistance or so what, how will you calculate I? R plus small r, very good. Epsilon divided by R plus R into capital R. Everything is given in the question. Epsilon is given, epsilon is 2 volt, small r is 0.1, capital R is 3.9. Volt, small r is 0.1 and capital R is 3.9 ohms. Calculate. .9 oda half varum 1.95, half of 3.9, so 1.95 varudha. The resistance of each arm of a Wheatstone bridge is 10 ohms. A resistance of 10 ohms is connected in series with a galvanometer. Then the equivalent resistance of the bridge across the battery will be. Wheatstone bridge la R1, R2, R3, R4 எல்லாமே 10 ohms. And another 10 ohms is connected in series with a galvanometer between the two ends. Diagram எப்படி வரும்? All these 10, 10, 20 varum, 20 and 20 are in parallel. 1 by 20 plus 1 by 20, 2 by 20, 20 by 2, 10 தான் வரும். Now here, if the bridge balancing condition is satisfied, no current will flow through this branch. Bridge balance condition satisfy ஆயிருக்கான்னு முதல்ல check பண்ணணும் கொடுத்திருக்கிற values வச்சு. So what is the bridge balancing condition? R1 by R2 is equal to R3 by R4. இந்த கேஸ்ல எல்லாமே 10 தான் இருக்கு. So you will get 1:1. No current will flow through this. Now what is the effective resistance? இந்த 10 ohm இந்த 10 ohm series la. So the effective resistance here is 20 ohms. What is the effective resistance in this branch? Again 20. And these two are in parallel to each other. So 1 by 20 plus 1 by 20 is equal to 1 by Rp. So 2 by 20, Rp is equal to 20 by 2. Answer is 10 ohms. Next, 10 identical wires, each having resistance 1 ohm, are connected in parallel. Identical aranda, what is the formula? If all the resistance are same, parallel in our general equation, R by N. So 1 by 10. How many identical resistors are there? 10 resistors are there. So 1 by 10 varum. Parallel all the resistance are identical. If the values of all the resistance are R, then the answer will be R by N. So here 1 by 10, 0.1 ohms. Fuse wire oda function enna? What is fuse wire? Low resistance. It should allow current to pass through it. High resistance and low melting point. What is the function of a fuse wire? In case high current flows through the circuit, and the circuit break பண்ணிடும். என்ன ஸ்பெசிஃபிகேஷன் கொடுத்திருக்கோம்? 5 amps fuse wire na 5 amps க்கு மேல போச்சுனா என்ன ஆயிடும்? It will melt. High amount of heat will be produced. As a result, due to the low melting point, it will melt. So high resistance, low melting point. 13th question. A cell of EMF 1.5 volt and internal resistance 2 ohms is connected to two resistors 5 ohms and 8 ohms in series. The potential difference across the 5 ohm resistor will be. Circuit diagram eppadi varum? A cell of EMF 1.5 volt having an internal resistance 2 ohms is connected to two resistors 5 ohms and 8 ohms in series. One point five. The potential difference across 5 ohms. Now, what will be the potential difference across 5 ohms? B is equal to I into R. அதுக்கு முதல்ல I கண்டுபிடிக்கணும். I will be same throughout the circuit. Circuitல என்னென்ன resistance இருக்கு? 2, 5 and 10. All in series. So, what is the total resistance? 15 ohms. I is equal to V by R. So 1.5 divided by 15. So 1 by 10. Current is 1 by 10. Now they have asked across 5 ohms. So 0.5 volt. The current through the circuit is 0.1 ampere into 5 ohm resistance will give you the potential difference. According to Kirchhoff's junction rule, at any junction of circuit B, the sum of the currents entering and leaving the junction must be positive. At any junction of circuit, the sum of the current entering the junction must be equal to the sum of the currents leaving the junction C. Across a metallic conductor of non-uniform cross-section, a constant potential difference is applied. The quantity which remains constant. Current alone will not depend on area of cross-section. மீதி எல்லாமே வந்து area of cross-sectionல depend பண்ணும். Electric field is inversely proportional to area of cross-section. Write down. Electric field is inversely proportional to area of cross-section. E is proportional to 1 by A, capital A. Drift velocity is also inversely proportional to area, 1 by A, and current density also. J is proportional to 1 by A. Current is the only factor which does not depend on area of cross section. Now, a wire has a resistance 12 ohms, it is bent in the form of a circle. The effective resistance between the 2 points on any diameter of the circle is, it is effectively like cutting the wire into 2 pieces and then joining it in parallel. இருக்கிற 12 ohms circle பண்ணிட்டு அந்த end, between the ends they have asked to calculate the resistance. So circle இருக்கும்போது total circumference இருக்கிறது 12 ohms. Now they have asked to calculate 1 by 6 6 வரும் parallel 1 by 6 plus 1 by 6 6 by 2 3 ohms வரும். Ohms is the answer. And the 12 ohm resistance ரெண்டு half கட் பண்ணாலே 6 6 வரும். 6 and 6 are in parallel. 1 by 6 plus 1 by 6 is 2 by 6. 6 by 2 3 ohms. Next one, a wire of length L is drawn such that its diameter is reduced to half its original diameter. Diameter reduces to half, which means radius also reduces to half. Area என்ன ஆகும்? Is drawn such that its area becomes, area எத்தனை வாட்டி increase ஆகும்? Sorry, decrease ஆகும். 4 times decrease ஆகும். The same effect you will have for length also. Length increases by 4 and area length twice இல்ல. See, area எந்த அளவுக்கு increase அல்லது decrease ஆகுதோ எத்தனை times அதே effect தான் lengthல இருக்கும். Don't confuse between radius and area. Radius எத்தனை வாட்டி increase ஆச்சு அது முக்கியம் இல்ல. Area எத்தனை times increase ஆச்சு இல்லைன்னா decrease ஆச்சு, that you have to calculate. Now that the diameter is reduced to half, radius is also reduced to half, which means area reduces to how many times? 4 times reduce ஆகும். So length must be increased 4 times increase ஆகும். So ரெண்டோட எஃபெக்டும் சேர்ந்து length increase ஆச்சுன்னா so much times you have to multiply. Area decrease ஆச்சுன்னா that also you have to multiply. Resistance will increase 16 times, it will increase 16 times. 4 into 4, 16 times it will increase, and answer will be 160 ohms. ஏற்கனவே it was 10 ohms. Now 16 times it will increase. Okay, length எத்தனை times increase ஆகுதோ அதே அளவுக்கு தான் area. I'm telling you the area, not the radius. Two similar headlamps are connected in parallel to each other. Together they consume 48 watts from a 6 volt battery. The resistance of each filament will be. Power க்கு என்னென்ன formula சொன்னேன்? I square R, V square by R and V into I. So they are similar and together they consume 48 watts. So ஒன்னொண்ணுமே எவ்வளவு பண்ணும்? Take the resistance of each of the filament to be small r and they are connected in parallel. So effective resistance எவ்வளோ? What will be the effective resistance when two resistors are connected in parallel, similar? R by 2. The effective resistance will be R by 2. Take R by 2 as the resistance. Power is given as 48. V is given as 6 volt. இதில் இருந்து find out R by 2 first. அதில் இருந்து small r you can calculate. 3 by 2, 1.5 ohms. இதை நீங்களே சால்வ் பண்ணுங்க. 10th ல இருந்தே சீரிஸ் parallel கனெக்ஷன் பண்ணிருக்கீங்க இல்லையா? எது சீரிஸ் எது parallel? 7 resistors are connected as shown in the diagram. You have to decide which one is parallel, which one is series, and then solve. You can even start from this end. 6 and 6 are in 6 and 6 are in parallel to each other. So that will be reduced to 3. Then in the 3 idloda resultant 3 edula parallel series ah. This 10 and 10 are also in parallel. Adhiyum reduce pannu. 5. So inga oru 5 varum, inga oru 5, inga oru 3. Now after this, see these 4 resistors obey the Wheatstone balancing condition. 5 by 5 is equal to 3 by 3. So no current will flow through this 8 ohm resistance. That circuit la illada madri dhaan irukum. It is, you have the Wheatstone condition when 4 resistors are connected to form a bridge and they satisfy R1 by R2 is equal to R3 by R4. Then 8 வந்து short பண்ண மாதிரி தான் இருக்கும். There will be no current through the 8 ohm resistance. So yes, 1 by 8 plus 1 by 8, 4. So 5 plus 3, this is in series. Here you will have an 8 ohms. In the 5 and 3 series. Here also you will have another 8 ohms. These 8 and 8 are in parallel. 1 by 8 plus 1 by 8, 8 by 2, 4 ohms. Solve பண்ணிட்டு வரும்போது, if there are 5 or 4 resistance, always check for Wheatstone bridge balancing condition. If it is there and the middle இருக்கிற resistance la, there will be no current. Here it is satisfied. 5 by 5 is equal to 3 by 3. For those who have finished this lesson, Kirchhoff's second law is a consequence of, first law is a consequence of conservation of charges, and the second law is follows the conservation of energy. The instrument for accurate measurement of EMF is potentiometer rather than voltmeter. Potentiometer தான் கொஞ்சம் கூட better இருக்கும். The direction of conventional current is the direction in which negative charges move, the direction in which positive charges move, positive charges move. Correct. Ammeter is always used in series with the element through which current is to be determined, parallel, series. Series la dhaan current same இருக்கும், and moreover ammeter oda resistance is very low. அதை parallel போட்டோம்னா இன்னுமே low ஆயிடும். High current will pass through the ammeter and destroy the instrument. Kirchhoff's first and second law of electrical circuits are consequences of conservation of electric charges and energy respectively. இதுவும் direct தான். P is equal to V square by R. Calculate R. They have given the power, they have also given the value of V, and they have asked you to find the resistance of the heating coil. You have noted down the numbers? Calculate and tell me. P is equal to V square by R. இல்ல 10.6 வருது, not 1.6. Check. Farzana, calculated. Dishita. Yes. Yes, yes. Tell me. Yes, tell me more. Can you please type? So answer is 10.6. 115 into 115 divided by 1250. 10.6 varum. Now, in a Wheatstone bridge, P is equal to 9 ohms, Q is equal to 11, R is equal to 4 ohms, and S is equal to 6 ohms. How much resistance must be put in parallel to the resistance S to balance the Wheatstone bridge? எப்படிமா பண்றது? Simple தான். இது ஒண்ணு மட்டும் சொல்லியிருக்கேன்ல, Wheatstone bridge ஓட திரும்ப திரும்ப அதே தான் சொல்லியிருக்கோம். P by Q is equal to R by S. That is your condition. How will you approach this sum? P by Q is equal to R by S வரணும். ஆனா Sல ஏற்கனவே 6 ohms கொடுத்திருக்காங்க, அதை மறந்துரு. Sல டோட்டலா எவ்வளவு இருந்திருக்கணும்னு கால்குலேட் பண்ணு. Forget that they have given you the value of S. If they had not given you the value of S, how would you approach the sum? The ratio should be same. P by Q must be equal to R by S. What is P by Q? How much is P by Q? 9 by 11 should be equal to R by S. 4 by some value. Now, cross multiply பண்ணும்போது so this should be your effective resistance. ஆனா ஏற்கனவே அங்க ஒரு 6 ohms இருக்கு. இந்த 6 ohms என்னவா கன்வெர்ட் பண்ணணும்? 4 into 11 by 9. அதுக்கு நான் என்னத்தை parallel போடணும்? So the effective resistance, that is RP, net effect of the two resistance. ஏற்கனவே இருக்கிற 6 ohmsக்கும் அதுக்கு parallel ஏதோ ஒரு amount நான் போடணும் இல்லையா? அதுவும் சேர்த்தா எனக்கு total எவ்வளவு கிடைக்கணும் 4 into 11 by 9 கிடைக்கணும் rp. So 1 by rp p by q is equal to r by s 4 by 11 தானே is equal to 9 by s. S is equal to தப்பா போட்டேனோ 9 by 11 is equal to 4 by s. So 44 by 9. Now 1 by rp is equal to 1 by 6 plus 1 by x. That rp is 44 by 9. rp is 44 by 9. So 9 by 44 is equal to 1 by 6 plus 1 by x. Therefore 1 by x is equal to 9 by 44 minus 1 by 6. Calculate. So you will get 10 by 264. So x is 264 by 10, 26.4 ohms. 28.1. If a wire of resistivity rho is stretched to double its length, then the new resistivity will be no change. Resistivity மாறாது. எப்படி மாத்தி கேட்டாலும் என்ன twist வச்சாலுமே resistivity will never change. It depends only on the nature. எப்படிதான் மாத்தி கேட்டாலும் என்னதான் நம்பர் கொடுத்தாலும் always remember that resistivity of the material will never change. Or another name for resistivity is specific resistance. Specific resistance கேட்டாலும் அதுவும் change ஆகாது. Assertion: there is no current in the metal in the absence of an electric field. Motion of free electrons is random. There is no current in the metal in the absence of an electric field. Motion of free electrons is random. Conductorsல நிறைய free electrons இருக்கு. Free electrons random எங்க வேணா மூவ் ஆயிட்டு இருக்கு. But it cannot come out of the conductor. அப்படி conductorல இருந்து வெளியில வரணும்னா நம்ம என்ன சப்ளை பண்ணணும்? You have to supply an EMF, electromotive force, to move the electrons out of the conductor. So he's telling that there's no current in the metals in the absence of an electric field because it is random. Net current னு பார்த்தா electrons will be moving to the right, some to the left. So net current இருக்காது. ப்ராப்பரா ஒரு current இருக்காது. So both A and R are true and R is the correct explanation because random இருக்கிறதுனால total net current is 0. Thirtieth question: as the drift velocity increases, the current through the conductor decreases. What was the relationship between current and drift velocity? I is equal to directly proportional. When the drift velocity increases, what happens to the current? It also increases. As the drift velocity increases, the current flowing decreases. So A is false. The current flowing through a conductor is directly proportional to the drift velocity. That is true. So A is false, but R is true. In a series combination of electric bulbs, the bulb of lower power emits more light than that of higher bulbs. The lower bulb in the series gets more current than the higher bulb. Seriesல எது கான்ஸ்டன்டா இருக்கும்? Current. So பவருக்கு என்ன equation போடுவ? P is equal to I square R. Lower power. Suppose you are connecting two different bulbs, say 60 watts and 40 watts. Which one will emit more? எது தரணும்னா the amount of potential difference அதை நீ calculate பண்ணணும். Potential difference வேறையா இருக்கும் because the resistance is different. வேற power, same current, but வேற potential difference and resistance is also different. So lower power emits more light இல்ல higher power emits more light? It is lower power emits more light than that of the higher power when it is connected in series. Okay va? So that is true. The lower power bulb in the series gives more current than the higher. Gives more current than the higher bulb. Series la enna current will be constant. So A is true, but R is false. Yes, C. Kirchhoff's junction rule follows from conservation of charges. Kirchhoff's loop rule follows from conservation of momentum. R is false, A is true. A single cell provides a feeble current. In order to get a higher current in a circuit, we often use a combination of cells. A combination of cells is called a battery. Cells can be joined in series, parallel, or in a mixed way. Two cells are said to be connected in series when the negative of one terminal of the cell is connected to the positive terminal of the other, and so on. Two cells are said to be connected in parallel if all the positive terminals of the cell is connected to one common point and the negative is connected to other point. In the mixed grouping of cells, a certain number of cells are identical, joined in series, and all such rows are connected in parallel with each other. Four cells, each of EMF 2 volt and internal resistance 1 ohm, are connected in parallel. Etana cell? Four cells, each having an EMF 2 volt and each has a internal resistance 1 ohm, are connected in parallel to a load resistor 2 ohms. Then the current through the load resistor will be four cells, each of EMF 2 volt na parallel la ellathileyume 2 volt dhaan varum. So throughout the voltage will be 2 volt. Now current, four cells, what will be the total resistance? Calculate the total resistance in the circuit. Four cells each having 1 ohms, that is in parallel, and or a 2 ohms load resistor. Calculate the total resistance in the circuit. Okay, write down the equation for this. I through this circuit will be I is equal to M into E divided by M small r plus capital R. I is equal to, the total current I will be equal to M epsilon divided by, where M is the number of cells, plus capital R. Maybe question parallel series solution they have given this. This equation is actually for series. Maybe a printing mistake because they have solved using series and the answer is 0.888 ampere. This is actually the equation for series if all the cells were in series. Parallel parallel equation epsilon will be same divided by inga enna varum idu series ku parallel irundha epsilon divided by r by m adiyum vera this r is also in parallel liya so adukku eta madri inga equation change agum. Use this equation now. If two cells out of n number of cells, each of resistance R, are wrongly connected in series, then the total resistance of the cell, n cells are there, each having an internal resistance small r. All of them are connected in series, but two cells are connected wrongly. What will be the total resistance? Resistance is not going to change depending on how you have connected the cell. Resistance garde and the resistance factor la mattum dhaan depend agum. So answer will be, you have small r, n number of small r connected in series, n into r, option B. Two identical non-ideal batteries are connected in parallel. Consider the following statements. The equivalent EMF is smaller than either of the two EMF. The equivalent internal resistance is smaller than either of the two internal resistance. Both 1 and 2 are correct. Both 1 and 2 are wrong. First statement is correct, but second statement is wrong. Second statement is correct, but the first statement is wrong. EMF cells are parallel. What will be the EMF that you get? Parallel. Decrease ஆகாது ஒரு சிங்கிள் செல்லோட சேம் ஒரு சிங்கிள் செல் நீ இப்போ 10 20 எத்தனை செல் போட்டாலுமே ஒரு செல்லோட EMF தான் அது தரப்போகுது. So the equivalent EMF cannot be smaller than either of the two. That cannot be. How can it be smaller than the smallest EMF? And the smallest EMF வரைக்கும் வரல, அதை விட கம்மியாக முடியாது. So first statement is wrong. The equivalent internal resistance is smaller than either of the two internal resistance. Yeah, that can happen. So 1 D, 2 is correct and 1 is wrong. To draw the maximum current from a combination of cells, how should the cells be grouped? Depends upon the relative value of internal and external resistance, mixed grouping, parallel or series. Yes. Parallel la pota maximum current கிடைக்குமா? Cells, fresh cells so இல்ல weak cells so எப்படி இருந்தாலுமே parallel la போட்டுட்டா you will get maximum current. Series. No, that will depend on the relative values of internal and external resistance, whether it is a weak battery or a fresh battery. So fresh battery இருந்தா எப்படி connect பண்றது advantages? Series la. If it is a weakened one, parallel. So internal resistance will depend பண்ணு and cell has got that factor of aging. Fresh cell load internal resistance ரொம்ப கம்மியா இருக்கும். By usage the internal resistance increases. And then I don't think we need to discuss this because potentiometer is out of your syllabus. You need to discuss potentiometer na in the Wheatstone oda இன்னொரு form தான் potentiometer. அதுலயும் அதே principle தான் யூஸ் பண்றோம். But இங்க என்னன்னா length of the wire மீதிலாம் it has got a primary circuit and secondary circuit. Primary circuitல இருக்கிற potential difference secondary circuitல இருக்கிறது equal ஆன உடனே there is a galvanometer which will show zero deflection. It is almost same like your Wheatstone bridge, how it works. But since it is out of your portion, I don't think we need to discuss. So that's all. Any other doubts? இதே கொஸ்டின் இன்னொரு வாட்டி டெஸ்ட் வச்சுட்டு பண்ணிடுவீங்களா? 5 marks, 5 minutes, 10 minutesல இப்பதான் சொல்லி கொடுத்துட்டேன் ஆன்சர்ஸ் எல்லாம். Or I'll ask any one of you to come and work it out on the board. Anyone, random. At least now all of you will tell the answer together, at least the how it has to be worked. I think we still have 20 minutes to go. Power dissipated, how did we do this one? எப்படி approach பண்ணோம்? திருப்பி please don't turn your notebooks, nothing. Close your notebooks. புரிஞ்சதா புரியலையா இவ்வளவு நேரம்? Till now you were sitting so silent. At least now you know these answers. எப்படி பண்ணோம்? ஃபர்ஸ்ட்லயும் செகண்ட்லயும் என்ன சேமா இருக்கும்? Potential drop will be same. Potential drop க்கு என்ன ஃபார்முலா? Ohm's law la V is equal to IR தான் ஃபார்முலா. First branch la let it be I1, second branch la let it be I2. So V ரெண்டு கேஸ்லயும் V same தான். So I1 into total resistance 4 will be equal to I2 into 8. அதுல இருந்து I1 I2 ரெண்டுமே கிடைக்காது, ஆனா ரேஷியோ கிடைக்கும். இல்லனா I2 கூட கண்டுபிடிக்கலாம். I2 into R 8 into I2 is equal to V into I is equal to 2 watts. அதுல இருந்து I2 கண்டுபிடிக்கலாம். I2 தெரிஞ்சிருச்சுனா you can substitute. That is how we solved this. Remember, the electrical resistance of a wire of iron is R if its length and radius both are doubled. Radius double பண்ணும்போது area என்ன ஆகுது? 4 times double பண்ணிருக்காங்க. 4 times increase ஆகுது. Double தானே? Resistance is double, so area is increased 4 times, length is increased 2 times. So length ஓட increase வந்து numeratorல வரும், area ஓட increase வந்து denominatorல வரும். So 2 by 4, the net effect will be 1 by 2. So the resistance will be halved, but specific resistance திரும்ப திரும்ப சொல்றேன், specific resistance resistivity never depends on the dimension. So the answer is the resistance will be halved and the specific resistance will remain unchanged. Up option 2. Then amount of charge in coulomb required to deposit 1 gram equivalent of a substance. 1 gram equivalent க்கு எத்தனை electrons நீ supply பண்ண வேண்டி வரும்? Avogadro number into the charge of a single electron. So you got the answer 96,500. Then this one was R1 by R2 is equal to R3 by R4. அதனோட ஒரு rearrangement தான். R1 by R3 is equal to R2 by R4. Potentiometer, what is, so why does it give so accurate? One thing, it never consumes a lot of current. Second thing, it is based on the condition that no current flows through the galvanometer when the potential, when the branches are balanced. Ohm's law is not obeyed by if two identical cells which are connected in series or in parallel supply the same amount of current. Series can equation இருந்தது, parallel can equation. I is equal to series இருந்தா இப்பதானே கடைசி எழுதி போட்டேன், n epsilon divided by n small r plus capital R. அது வந்து எதுக்கு? சீரிஸ்க்கு. parallelக்கு epsilon divided by r by 2 plus capital R, external resistance. Then you equated epsilon got cancelled and then you got I think எவ்வளவு கிடைச்சது? 2 கிடைச்சதோ? 2. Okay, now 8th question. Battery connected of a variable number of B. Then the internal resistance of a cell is given. It is connected to a external resistance. What was the formula? B is equal to I into R, but I is equal to epsilon divided by R plus R. Epsilon வர இடத்துல என்ன பண்ணோம்? 2 divided by 3.9 plus 0.1 into 3.9 divided by 2 you got. Finally 3.9 divided by 2 you got, which is 1.95. The resistance of each arm of a Wheatstone bridge is 10. So மேல இருக்கிற 10 உம் 10 உம் சீரிஸ்ல, கீழ இருக்கிற 10 உம் 10 உம் சீரிஸ்ல. So 20 in parallel, 1 by 20 plus 2 by 20, 20 by 2, 10 ohms. Two identical wires each having a resistance 1 ohm are connected in parallel. 10 identical wires. So 1 by 1 வரும், எத்தனை வாட்டி வரும்? 10 வரும். So 1 by 10. General equation R by N. R by N, so 1 by 10, which is 0.1. Fuse wire should have a cell of EMF 1.5 and internal resistance 2 is connected to two resistors 5 and 8 in series. Everything is in series. So current கண்டுபிடிக்கிற current into V is equal to I into R. I கண்டுபிடிக்கிறதுக்கு total potential, that is 1.5 divided by the total resistance, which is 8, 5 and 2 in series. 8 plus 2, 10 plus 5, 15. 1.5 divided by 15 போடும்போது you will get the current into the resistor. So 0.1 into 5, 0.5 volt. Then this one is C. The amount of current entering a junction should be equal to the amount of current leaving the junction. Wheatstone bridge la, how did we solve this? P by Q should be equal to R by S. But S ஓட net என்ன resistance இருந்திருக்கணும் அதை first கண்டுபிடிச்சிட்டு அதுக்கு இந்த 6 ஓட என்ன parallel போட்டா அந்த value கிடைக்கும். Remember how we did this? P 9 by 11 is equal to 4 by X. அந்த X எவ்வளோன்னு கண்டுபிடிச்சிட்டு X 1 by X is equal to 1 by 6, sorry, 1 by 6 plus 1 by X is equal to that value, whatever you got on the ratio. The resistance of 4 ohms PQRS in a Wheatstone bridges 10, 30. இது solve பண்ணலையோ, இது விட்டுட்டோமோ. 10 by 30 is equal to 30 by 90. The EM, we didn't do this, huh? Then do this. The resistance of 4 ohms PQRS in a Wheatstone bridges 10, 30, 30 and 90. The EMF and internal resistance of the cell are 7 and 5 ohms. If the galvanometer resistance is 50, the current drawn from the cell will be, the current drawn from the cell I is equal to total potential V by epsilon by R. Net resistance கண்டுபிடிங்க. 10, 30, 30, 90 எல்லாமே அல்ல. PQRS P. எது சீரிஸ்ல எது parallel வரும்? PQ R and P by Q is equal to R by S. P U R series la, Q S series. 10 and 30 will be in series, 30 and 90 will be in series. அப்புறம் அது ரெண்டும் ஒண்ணுக்கு ஒண்ணு parallel. Work out, find out the total resistance. 30 வருதா? 30. So total potential in the EMF supplied is 7. 7 divided by 30 பண்ணினா current கிடைக்கும். Seven divided by 30 plus அதனோட internal resistance வேற இருக்குது. That internal resistance also has to be added to the total resistance. Total resistance 30 sonia, 30 plus 5 is 35. 7 divided by 35.
Ma'am.
Yes.
Excuse me, ma'am.
Yes, ma'am.
The stance is 0.2, ma'am.
0.2. Yes. 0.2.
Thank you.
Now 28th sum. The resistivity, even when it is double the length, the new resistivity will not change. There is no current in the metals because the electrons are moving in random. 29 வந்து A. 30th one, A is false, R is true. And idhula lower power will have higher light. Then Kirchhoff's junction rule. And finally this one. This was the series nu poda sonnen. There was a spelling mistake. It's not parallel, it is series and they have used and the formula dhaan put pannirukanga. If two cells out of n number of cells, each of resistance is given n into R, then equivalent resistances. So you have any other doubts? Shall we wind off? Any other doubts? That's all. And the equation ku na sollirundhen, electric field is inversely proportional to area, note that point. And then drift velocity is also inversely proportional to area. Current density is also inversely proportional to area. Yeah. Thank you, ma'am.
Thank you, ma'am.
Yes. Thank you, ma'am.
ஆளுக்கு ஃபோன் பண்ணுறோம்.
நீங்களும் ஒரே ஸ்கூல்.